Well, here we are, the dreaded Chapter 8 on subnetting IP networks, which hopefully won't be as bad as it could be. We'll try to make it as simple as possible, avoid as much binary as possible when we get into subnetting IP networks. So I'll try to show you a couple techniques to make this as quick as possible when you're taking the CCNA exam, because time is going to be of the essence when you take that test. So let's get into subnetting IP networks. We're going to be subnetting IPv4, looking at addressing schemes when we need to subnet a network range into different networks or subnets, designing considerations for IPv6 as well, which is a little bit easier. So, I'm just going to go through as we move. So, broadcast domains. Each, network has a broadcast domain. Your broadcast domain is all the local devices on your network. Okay, so each interface on a router would be considered its own broadcast domain. Whenever there's a broadcast packet, then it goes to every device in that broadcast domain. The problem with large broadcasts, they can slow down the network. It slows down devices because they got to accept and process each broadcast. So it's causing you to have a less efficient network if you have a very large broadcast domain. You can see in this example we've got 400 users in one domain. So we can perhaps get some more speed out of our network, cause our network to work a bit more efficiently if we can divide that up, create smaller broadcast domains. Alright, so the solution to having a large broadcast domain would be to create different subnets or portions of your network. Okay, and we need to know how to do that. We need to know how to take one network range, like the example we have here, 172.16.0.0, which is a /16 address, and subnet it out into different portions. It's really not that hard, maybe. Well, we'll see. We'll see how you feel about it. And we'll go through here. So that's what we're looking at doing. That's really the basis or groundwork of this chapter, is learning how to subnet out, essentially dividing up a larger network range into smaller network ranges as you meet the demands of your network. Okay, so again, reasons for subnetting are not only limited to broadcast domains. You may have networks that you don't want to have sharing information back and forth. You may have a sales team, a marketing team, HR, and you want them all on different networks because they need access to different servers, different security policies in place, and it just makes it easier to manage them if they're just not all on one large broadcast domain and they're on their own LAN. Okay. Remember, each interface on your router is going to be considered a broadcast domain, okay, or a network. Okay, so you've got 1, 2, 3, 4, 5 different networks here in this example. So again, you could subnet out for different services, different groups. In this example, we've got administration, human resources, students, accounting. So that could be a reason. We just talked about that. You might subnet by device type. You've got all hosts here, all servers, all printers, all on their different own subnets. Okay, so those are reasons for subnetting. So we get into subnetting the IPv4 network. So this slide refers to subnetting networks on the octet boundary. When you're giving a subnet mask of some sort, it's going to be all 255s up to some point, whether it's 8 bits turned on, which would be 1255, 16 bits turned on, which is going to need to be 255 or the /24, which does make things a little bit easier when you're only working on this last octet here. Okay, that's going to be the easiest situation. Typically, and I don't think you're going to see even in any of this material, a situation where we're subnetting into the second octet here. Then you're working with above 65,534 hosts, and if you're working with that many hosts on a network that you're managing, you're probably pretty high up. So we don't really deal with that, I don't think, at all in this material. But we will deal with the /16. So we need to know how to deal with that. And if we know how to deal with the fourth octet here and the third octet, you could just use math and apply it, and you should be able to deal with this situation if you were ever to run across it. But chances that you are subnetting, again, a network of that size, not very great. Okay. And on this slide we have the /16 and the /24 networks, and how many hosts are possible there, how many possible subnetworks there are in each range. So the host for a /16, you have a host range of 65,534. We'll talk about why that is in just a second. And then this last octet, you only go from 0 to 256, and we know that the first address in any address range is the network address. The last address is the broadcast. So you only have a possibility of 254 hosts in a /24. Now let me see how far I want to go here. Okay, I think I will stop here as far as the PowerPoint goes. Well, I guess this is a good example of why we'll switch it up. So based on bits borrowed, we've talked about borrowing bits, and this is going to be an easier range. We start with the /24, and we're borrowing into the fourth octet here. Okay. So if you borrow 1 bit, you end up with 2 subnets you can create, which supports 126 hosts each. Okay, and we'll talk about why that is in just a second. Borrowing 2 bits in, you get 4 subnets supporting 62 hosts each. Borrowing 3 bits, you get 8. 4 bits, you get 16, 14 hosts, so on, so forth. Okay, how do we come up with those numbers in the easiest way possible? Well, we're just going to use our chart a bit more. Okay, so that chart we created in the last chapter, we're just going to modify it a bit, and don't let it scare you at all. Okay, it shouldn't be too scary. It's the same chart we had up here at the top. All right, I've just added basically the reverse of this chart at the bottom down here. Using this chart up top, we can get the number of addresses that are going to be involved in an octet based on how many bits we've borrowed. And using this chart, we'll get the number of networks. So for instance, let me go ahead and I'll kind of switch back and forth here. The first example we have here is if you borrow 1 bit from the fourth octet, it creates 2 subnets supporting 126 hosts each. So a /25 would be borrowing 1 bit. Okay, so you just have a 1 here, and the rest of this would be 0. Okay, we see that it's going to create 2 subnets supporting 126 hosts each. Okay, great. Where do we get that 126? Well, this number is the amount of addresses total that'll be in that subnet. Okay, we know that the first address is network, last address is broadcast, so it's 128 minus 2 is the number of hosts that you could have on that subnet, because we have to subtract the network address and that broadcast address. So this becomes 126 hosts. That's where the 126 hosts comes from. Okay. And then we have 2 subnets that can be created. All right. If we just take a look down here, that's what you get if you lose this chart. Just start at 2, go on up. I mean, 128 can only go into 256 2 times, so that's where you get this 2. Okay. That's the total number that we can have in that last octet of the subnet is 256, so 128 goes into it twice. We can get 2 subnets if we borrow 1 bit, and we can get 126 hosts because we have 128 total addresses, and we have to minus 2 from that. And that's going to be consistent. You're always going to take this number minus 2, and that's the number of hosts This number is the number of addresses, but that number minus 2 will be the number of hosts. So going on down the list, if you borrow 2 bits, you create 4 subnets, 62 hosts each. Okay, so if we have a 1 here as well, we take that 64 minus 2, that's our 62 hosts each. 4 down here, that's how many subnets can be created with a /26 or /26 or borrowing 2 bits in that subnet. And you've got the chart giving you those numbers right here. Okay, so the chart will make this pretty dang easy. And it just goes on from there. So if we borrow, let me just try to squeeze that in there. So if we go into the 3rd bit, borrowing 3 bits, that gives us a 32 up here. 32 minus 2 is 30. 8 subnets, 8 and 8. Okay, and it will keep on going on like that, just trust me. I mean, you can see there our values, they match up down here. And we never go past this line here. Okay, that's a /30, the 4 and the 64. So if you go past the /30, you don't have any assignable host addresses in a range. So you never borrow any more than 6 bits into this last octet. Okay, don't worry about this area down here just yet. In fact, you can't see that area. It's off screen right now. Anyhow, so yeah, this is the range we're concerned with. These two, we don't borrow that far into the last octet. Okay, so this chart should help quite a bit. So easy to create. If you can create the first chart that we used last time for binary, okay, that's just 120 or 1, 2 multiplying by 2 up to 128. Down at the bottom of that chart, you can just start at 2, keep on multiplying by 2 to 4 times 2 is 8 times 2 is 16, on down the reverse direction. And if with those two things combined, you get your number of networks. You also get your number of addresses up here. If you take that number of addresses minus 2, you get the amount of hosts in a subnet based on the amount of bits you borrow. Okay, hopefully that's clear. We'll be using that technique as we go through a couple exercises here in just a second. All right, so I'm going to bring up an exercise that we'll be doing in class and do a little bit of it here on the video so you can see how we're going to use this chart and also what's going to happen when we get into the 3rd octet and have to subnet there. So here we go. Hopefully this won't be too bad. So here we are. This is one of the subnetting scenarios we'll have. In fact, I'll probably just have you do scenario 2 so you don't just copy this video as you're working through it. So here's our topology, okay, and my addressing table, and let's see what they're going to give us. All right, so we've got to subnet this 192.168.100.0/24 network into the appropriate number of subnets. Okay, so based on the topology, how many subnets are needed? Okay, so we're going to take a look at that topology. How many subnets are needed? I need 1 for this link on the router, 2, second link here, 3 for this link on route R2, 4 for this link G01 on R2, and I need 5 because I have a link between the 2 routers. That also needs to have a subnet. Okay, so there we go there. And we're just doing standard subnetting. There's going to be an exercise after this where we'll do something called variable length subnet masking, but we're just going to do standard subnetting here. Okay, in which case all of our subnets will have the same size. So here we go. Let's answer some questions. So based on the topology, how many are needed? We just determined that was 5. Okay. How many bits must be borrowed to support the number of subnets in the topology table? Okay. So they're asking us how many bits do we need to borrow in order to have at least 5 subnets. At least 5 subnets. So how can we figure that out? Well, I'm going to go back to that table that we had back here. Okay. So I'm going to need to at least borrow 1, 2, 3 bits. Because this is my number of networks, or I should put maybe number of subnets over here, so that's a little bit more clear. Maybe I'll do that. Number of subnets. Okay. So 2, 4, 8, I'd have to borrow 3 bits, okay, to support 5 different subnets. All right, so the answer is 3. I'd have to borrow 3 bits. Okay. So how many bits must be borrowed? 3. How many subnets does this create potentially? Well, we just saw that. That was 8. Okay, that is potential to create 8 subnets. I'll minimize it, I guess. So we get 8. How many usable hosts does this create per subnet? Okay, we already saw that in the spreadsheet again. So if we borrowed 1, 2, 3, I'm just going to put those bits here. 1, 2, 3. Just hit the microphone. Nothing fell. You've got a 32 up there. We know we're going to take that number, which is the number of addresses in the 4th octet, or number of addresses that are available if we borrow this many bits, minus 2 for that network address and that broadcast address, and we'll get 30. Okay, so that's how many hosts we can have in that in each subnet. So we can have 30. If our answer is less than 25, then we borrowed too many bits, so we're good. Okay, we're right where we should be. So let's go ahead and try this out. Down here, it wants me to give the binary value of each of the first 5 subnets. I'm not going to do it. I don't think I'm going to ask you to do it. I'm going to try to avoid binary as much as I can in this exercise, because you can avoid binary almost completely in your CCNT and CCNA. Works just fine just using the chart. So I'm going to skip past here and go down to my addressing table. Okay, so here we go. So the first subnet address, we can see here it's 192.168.100. It's going to be .0. That's always going to, if that's the range we're starting with, it would be a .0. Okay, so subnet address is 192.168. What was it? A 100.0. Okay, let me go ahead and add in what the subnet mask is. Okay, it asked me to give the binary value of the subnet mask here. I shouldn't have skipped that. I'm sorry, the decimal value of the subnet mask. That should be pretty easy. We said that, well, we're going to go ahead and how many bits are borrowed to support the number of subnets in the topology? 3. Okay, so we borrowed 3 bits. If we borrowed 3 bits, 1, 2, 3, we can add these up and get the last value of that subnet mask, 128 plus 64 plus 32. Okay, that's 224. Or you can take this value in the chart above the last bit borrowed, so in this 3rd position, take this 32, take 256 minus that 32, and you'll also get the subnet, the decimal subnet value there. So 256 minus 32 is 224. If you add up 128 plus 64, that's 192 plus 32 is 224. Okay, so either way, you can get that either way. So my subnet mask is 224 there. All right, hopefully you're still with me. Maybe take some notes, go back, re-listen if you need to. All right, so my first subnet address is here, or my network address. The term network and subnet are interchangeable, are used interchangeably. Most networks are a subnet of some bigger network, so you can pretty much interchange those terms. All right, what's my first usable host address? Well, the 192.168.100. I'm just going to copy that because I'm going to be using that all over the place. Maybe I'm not going to copy it. Maybe I have to select it to copy it. There we go. .1. It's first usable. Okay, that's the subnet address. This is the first usable. How big is this network if I'm using the subnet mask I did here? Okay, or in other words, borrowing 3 bits into the 4th octet. So with this subnet mask, borrowing 3 bits, okay, the amount of addresses I have in each subnet is 32. Okay, so we're using this number for a couple different things. Going back to Word, here we are. Hopefully this is big enough. Maybe it isn't. I should zoom in a little bit more perhaps here. There we go. So if there are 32 in each range, it goes from 0 to 31. All right, 31 is going to be the broadcast. Dot 31. Okay. First address, network address, last address, broadcast. Okay. Last usable is just going to be one before that. So let me go ahead and paste that in. /dot 30. Okay. That does add up to 32 addresses. 0 counts as an address through 31. That gives you 32. Okay. So that's 1. All right. So moving right along, I'm going to go ahead and, well, create the next range. Next range is going to start where the first one left off. All right. This is the broadcast address. Next one's going to start at 31. I mean, sorry, not 31. Sorry, not 31, 32. Don't let me confuse you. So it's going to increase by this number here. Okay, still this number. So if it's 32, then we get, well, a dot 33 is our first usable. Last usable is going to be a dot 62. Okay. Our broadcast address is going to be a dot 63. I'll just tab on down. Okay. And then this 32 plus another 32 would be a 64. So my next network starts at dot 64. First usable, 65. I don't think I'm going to probably stop after this. Last usable is going to be 94. Broadcast is going to be a 95. And then your next network would start at 96. And you're just going to go from there, increasing by 32 every time. Maximum amount of hosts in each network, 30. And you use that addressing table to finish out the lab, basically. Based on that addressing table, you will configure the interfaces on the router, and everything should work out. So that is going to be an easier example where we want all of our subnets to be the same size. We're only using the 4th octet. So this is really the easiest example we'll have. Okay, I'm going to do another example using the 3rd octet and also using a technique that's also in the chapter called variable length subnet masking, where you don't want all of your subnets to be the same size. So we'll do that next. So in subnetting the next topology, we have a bit of a unique situation. So far we have been subnetting with a /24 CIDR notation, or a normal subnet mask, quote unquote normal, of 255.255.255.0. Okay, and everything's been working out pretty well. Hopefully that's understandable. This is going to be a /17, which is going to add a couple different twists to it. First of all, we're subnetting in the 3rd octet, which is going to change our values a little bit. And then we have a /17 rather than a /16, which means the number of networks we can create kind of shifts over a little bit, and I'll try to show you how that works. So first of all, how many subnets are there? I'm just going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. So that's our answer here is 9. And how many bits should be borrowed to create the number of subnets we need? That's where things get a little bit interesting. So if we come back to our chart here, let me make sure it's in frame. It looks like it is. Okay. So let me scroll up. Get rid of that. We have been counting the bits we borrow. 1 bit would be, we can create 2 subnets. 2 bits could be create 4, 3, 8, whatever. The unique situation is we're in the third octet with a /17 network that we're cutting up into smaller pieces. Okay. If we're in a /17 network, that means we already have a 1 basically here instead of a 0 in the third octet. Whoops, that shouldn't be so many decimal places. Make sure all those don't have that many decimal places. Okay. So we already got a 1 here, basically in the third octet, and a bunch of zeros. Okay. So at this point, you just have 1 subnet you could create. I'm sorry, not 1 subnet. At this point, you already have, if you're in this position, only 1 network that can be created because that's the original range of values. Okay. So this is the network we're subnetting on. It already has a 1 here in the third octet. We're going to start borrowing bits from this position. All right, because we're a /17. What that means is this number of subnets chart kind of shifts over, because over here, that bit was already turned on from the original network that we're subnetting from, the /17. So I'm just going to take this range and move it over 1 slot, and that's a number of subnets based on bits borrowed. Okay, because now we start borrowing bits from this point, not from over all the way at the left like we have been with our /24. Okay, so if we borrow 1 bit here, we get 2 networks. If we borrow 2 bits, we get 4, so on and so forth. So now we need to ask ourselves, how many bits do we need to borrow, okay, to create a network that supports 9 subnets? And the answer is we need to borrow, we need to borrow 1, 2, 3, 4. Okay, that gives us 16 subnets or networks that we can create if we borrow those 4 bits. All right, again, this 1 was already here. That's why we don't start counting from here. This was the original network that we're subnetting or breaking into smaller pieces. This is where we're starting to borrow bits. So our chart has shifted a little bit to overlap where we start borrowing bits at. That would apply if it were a /18 network that we started with. We'd shift it to the right 1 more spot. So on and so forth. So just, I know that's a different concept, and it's kind of a bit much to throw at you as we start subnetting in the third octet, but that's something you're going to need to know. All right. Okay, so I've got a number of addresses that I can make in this third octet as well. All right. Our number of addresses in the fourth octet were up here. Where did these numbers come from? Well, it's just this fourth octet being double on itself and continuing on. So we went from 1 to 2 to 4 to 8 to 16, 32, 64, 128. 128 times 2 is 256, times 2 is 512, times 2 is 2024, so on down the list. So that's where these numbers are coming from, because we have shifted into the third octet. Okay, groups of 8 octets. All right, and it would continue from here. From here, it would go to 64,536, I think it is, if we went to the left into the second octet. So it just keeps on going down the list. All right. If you want to if this makes it easier for you to make your chart, you can think of it as the original fourth octet. If you multiply each value here times 256, that's what you get down at this position. So 1 times 256 is 256. 2 times 256 is 512. 4 times 256 is 1024. And onwards we go. Okay. I'm going to place my zeros here just for good measure. All right. So we've borrowed 1, 2, 3, 4 bits. Okay. 5 bits borrowed total. Okay, in this octet, or 5 bits on total, I should say. In this octet, we borrowed 4. So let's answer some more questions. So how many bits should we borrow? We determined that was 4. So type in 4. How many usable host addresses are there in this scheme? Well, let's take a look at the chart. If we go over to the last bit borrowed, or the last bit that's turned on, I should say, we've got 2048. We know we need one address for the network address, one address for the broadcast address, so that's 2046 is what we'd get there. Okay. And what is the new subnet mask in dotted decimal format? Well, let's find out. We still use these numbers up here, okay? That is still something we're going to do no matter what octet you're in. It'll tell you your block size. It'll tell you how you calculate your subnet mask. What else? That number is very important. Our block size means how many hosts do we have per network? How many hosts do we have per network? So that's block size. So we have 8 hosts per network, which means our networks start at each 8 values as we increase, okay? Each 8 decimal values. And you'll see that as we fill out the chart in just a second. So that's the block size. Also, you can use this number to find out what your subnet mask is, okay? You could either just add up all these values going down to the last bit that's turned on, 128 plus 64 plus 32 plus 16 plus 8. Or you can take this value and just, go and subtract it from 256. You'll also get your subnet mask. Okay, so 256 minus 8 is 248. So if I come back here to my document, we've got 255.255. Since we're in the third octet, 248.0 is our subnet mask. Okay. How many subnets are available for future use? We needed 9. We ended up with 16. 16 minus 9, 7. Okay. So hopefully that makes sense. If you need to go back and watch that a couple times, don't hesitate to do so. And we'll start filling this out. Subnet address, first usable host, last usable host, broadcast. This can be made easier if you just start filling out your subnet addresses first. So I'm going to go with my subnet address, which was, whoops, it's not here. I need to scroll up to find it. It is 126.16.128.0. Okay. Let me look at that again. 16.128.0. Okay. 172.16.128.0. Cool. All right. That's going to be our starting. That's the network we are cutting into smaller pieces, or dividing up into smaller pieces. So that's going to be my starting point. That's always going to be your starting point. I mean, your first network is the network you're cutting up into smaller pieces. All right. So if I just fill this out as far as my subnet addresses go, it'll make things a bit easier. I'm going to type in 172.16. Plus that 128 plus 8, that's our block size, is 8. That's why that 8 value is important here. Okay, how many bits are turned on? That's our block size. It allows us to make our networks easily. So I'll go ahead and type in 136.0. Okay, so that is correct. Moving on down, 172.16.142.0 is my next network, and I can keep on going. I'm going to stop here though. 1 4. Oh, sorry. 1 6. That's why it doesn't make sense in my head, because I did wrong math up here. That's actually a 144. Okay. It's supposed to be a 152 there. Yes, .0. Okay. There you go. Mistakes everywhere. But we clean them up, hopefully, quickly. So, here we are. This is going to make filling out your chart hopefully a lot easier, because if you know your subnet addresses, getting your broadcast address, you got to roll back one from that. Last usable, roll back one more from your broadcast, and then first usable is just this plus one. So it should be easy to fill out your chart from this point. So my broadcast address here for subnet 0, or the first one I'm creating. All right. This can throw you a little bit because we're in the third octet. Remember that the fourth octet still has usable hosts, and it's still a value that's going to increase. So where you might think it's 172.16.135.0, that would be wrong. It's actually going to be 172.16.135.255. Okay, because we're still using the fourth octet to increase. You got to remember that. That plus one digit in the fourth octet would give it 172.16.136.0. Okay, so you have that there. And our last usable would just be, well, our broadcast minus 1, 16.135.254. And then our first usable Alright, and you're just going to fill out the rest of it like that. So if I'm looking at the 136 network, subnet 1, my next network's 144, so I've got 172.16.135.255. Nope, 135, I'm copying that, 143.255. Okay, and rolling that back one, 172.16.143.254, and 172.16.136.1. Okay, and I'll just do one more. 172.16. And what's it going to be for this? 152 is the next network, so it's going to be a 151.254. Okay. So you'll fill out the rest of it like that. That's how it's going to go as well. Another reason this block size, another reason this block size is important, this block size of 8. We talked about ANDing before and trying to figure out what network a certain IP address is on. Well, if you use this block size, you can find out what network any IP address is on by using the block size. So for instance, if we had a IP address of 172.16.149.122, okay, it's on 172.16.149. all right, you just need to figure out what the nearest address is in blocks of 8, okay, in blocks of 8, to figure out the network. All right, so if you had a .149, 172.16, let me go ahead and type it up here, 172.16.149.211, we'll say. Okay, I'm not even going to pay attention to 211, so I know this is being subnetted, or we're borrowing bits in this third octet here. Okay, so that's where my network address is. All right, so I know my block size is 8 here in this network. So if I am just counting by 8s, I need to see what the closest thing to 149 is, basically. And if you count by 8s, I'm not going to do it with you, but you'll get to a 144. All right, that's the next network after that would be a 152. So that's above this range. You're going to know that 144.0 is the network based on that block size. All you'd have to do is count it by 8, see what the closest value is. It would be a 144, so you'd know this IP address would be on the 172.16.144.0 network, just working in the third octet. Okay, we'll talk about that more in class if that's kind of not sticking right now because I'm just quickly going over it, but that's another reason the block size is important. All right, so we'll move on from here. All right, this is our last example of subnetting that we're going to see for IPv4. We took a look at fourth octet subnetting, third octet, which is really all you'll have to do, pretty much. I mean, I would be surprised if you see a question on the second octet, but based on what we did for the third octet, you should be able to venture into the second if you really needed to. What we're going to take a look at here is something called variable length subnet masking, where you don't just use one set subnet mask for all your subnets. You are going to use just big enough mask to accommodate the hosts in a given network. So we're going to end up with a few different subnets here. A couple of them will be clones, it looks like. 2 of them, to be exact. But we're going to basically have different subnet masks that are just big enough to accommodate the hosts in a given subnet. Okay. We're going to subnet the address 192.168.72.0/24 for networks that have the following requirements. Okay. So variable length subnet masking, whenever you're going to do this and use different subnet masks on different networks, you're always going to go from the largest to the smallest network. Otherwise, you will run into issues. Okay, just trust me on this. Your numbers will not line up right unless you subnet from largest to smallest. So that's what we're going to do. We're going to subnet from largest to smallest. Okay, so our largest network in this, we've got 7 hosts, 15 hosts, 27s, 58, and 2, I'll just type in hosts, IP addresses for one of our entries. All right, so here we go. We're going to go ahead and take care of this 58 IP address. All right, so we know right away, since if it's the first address that we're going to subnet down here, it's going to have this network address here, 192.168.72.0. That's its network address. Okay, we just need to figure out what the subnet mask is going to be. In fact, I'm not even going to type in subnet description over here. I'm just going to make that subnet mask so we can see what that ends up being. Okay, and let's take a look. So 58 hosts, going back over to our chart. Okay, if we need 58 hosts, we're going to borrow 1, 2, that's 64 addresses available. 32 is not going to work. Okay, so this is what we're looking for. 64 is going to be the closest thing to 58 it was, or 64 minus 2, which are actually our usable host addresses. Okay, otherwise known as 62. So we're borrowing 1, 2 bits there. 1, 2. Okay, jumping back over here. So our first usable address in that range is going to be 192.168.1.1. Since it's a 64 here, okay, going back, our broadcast is 192.168.1.63. Okay, first usable host address, broadcast address, that's what we get. What's our subnet mask? Well, if we take 256 minus 64, we're going to get 192. So that's our subnet mask, is going to be 255.255.255.192. Let's see if I can widen that just a little bit. So there we go. And that's a /26. Okay, it's a /26. So we needed 58 hosts there. We ended up with a possibility of 62. All right. So that's our first network that we subnetted out. We just figured out what we could do to accommodate 58 hosts. We're going to go to our next entry, which we need 29 hosts. Okay. So for this 29 hosts, what can we do? Well, first of all, let's take a look at where our network address is going to start. It's going to start at the end of our previous. So it's going to be 192.168.72.64. That's our network address. We just need to figure out how big that network's going to be. So we'll take a look. All right, wiping out that. Still good. We're still in frame here. So we needed how many? 29? Yes, 29. So we'd borrow 1, 2, okay, 3 bits, actually, if we're trying to get as close to 29 as possible. We're going over to the 32 there. All right. 32 minus 2 is 30, and it's still larger than 39. We don't have much wiggle room there, but we are told that we only need 29 addresses in that network, so that's what we're going with. All right. So we're using 3 borrowed bits in this 32 here. So our addresses would be 30 that are available, and the entire range is 32 addresses. So this 64, the first usable address, of course, is 192.168.1.65. Okay. 64 plus 32 is 96. All right. But that's where the next network is going to start, is at the 96. The broadcast is going to be at the 95. So 192.168.1.95 is going to be your broadcast address. Next address starting at 192.168.72.96. Okay. All right. So this is how it's going to end up going. Oh, let me give you the slash. The slash is going to be /123, so that's going to be a /27. 24 plus that 3 borrowed bits is going to be a /27. All right. Subnet mask is going to be 256 minus that 32 here. 256 minus 32 is going to be 224. Okay. So there we go. We got that network with 29 in it. All right. So we go down to, we need a network of 15 that supports 15. All right. This is a little tricky, just a little bit. So we need 15 hosts. So we're going to click on over here, get rid of these borrowed bits. We've got 126, or 128, 64, 32, 16. We need 15 hosts, but, of course, 16 minus 2, that's going to give you 15. Not going to accommodate, I'm sorry, 16 minus 2 is going to give you 14, not going to accommodate those 15 hosts. Okay, so we do have to use the third bit borrowed here. So we can't go all the way to the 16 because it only gives us 14 hosts. We need to use the next spot here. So we're only borrowing 3 bits rather than 4 because 16 does not work. Okay. Again, my computer is behind me. All right, so it's going to be the same type of situation we had in the upper section here. So again, it's going to be a /27. Okay, same subnet mask, same exact subnet mask. 192.168.72. Oh, I'm confusing some of you. I know it because I messed up on my typing again. Sorry for being so entertained by my mess ups. 97. I'm not supposed to have 1s there. I'm supposed to have 7 2s there. Why? Why is that the case? Okay. There we go. And whoops. All right, let me just double check everything because it looks right now. I don't know why I was placing 1 there. I was placing 1 because I was on autopilot. Actually, I do know exactly why I was placing 1. It was autopilot. So it's all correct now. All right, I've got correct first usable host, correct network addresses, and everything. I'm going to go 192.168.72, not 1. All right, dot 96 plus 32 is 128, so my broadcast is going to be 127. All right, next network address 192.168.72.128. Okay, getting close. Almost done. So I need to be almost done, otherwise it's going to go over an hour. How many hosts needed? 7. Okay. In this situation, we're going to take a look at the chart again, and 8 again is not going to work. 8 minus 2 is 6, so we need to borrow all the way over to the fourth bit, and use this 16 instead. Okay, can't use the 8. 8 minus 2 is 6. So that's going to be a slash 28. And now, of course, that's a little too wide. Let me go ahead and, there we go, adjust. First address 192.168.72.129. All right. 192.168.72.128 plus 16 is 144. So this is going to be 143. All right, our subnet mask is going to be this 16.256 minus 16 is 240. So 255.255.255.240. Okay, we got that there, and we're almost done. So our next network begins at 192.168.72.144. How many do we need hosts? 2. Okay, this one will be easy, hopefully. Only need 2. So if we need 2, if we borrow bits all the way over to the 4 here, 4 minus 2 is 2 exactly. That's a slash 30. That should be pretty easy. So here we go. I'm going to go ahead and fill that out. 192.168.72.145 is the first usable. The last usable is just that plus 1. 192.72. I'm sorry. 168.92.168. At this rate, we'll never finish. 146.7. Okay. 46 would be the other host address that's available. Subnet mask of 255.255.255. And what's 256 minus 4? 252. Alright, so that's variable length subnet masking. You're going to start with the largest one and work your way down. You want your number of hosts supported by your subnet mask insider notation, the bits you borrow, to be just enough to fit the number of hosts you need. Okay, working from the network with the need for the most amount of hosts down to the need for lowest amount. Hopefully that makes some sense. I know this is going to be a long video, but this is important stuff. We'll discuss it in class, and well, there will be a second part to this video on the IPv6 version of it'll be pretty short. It'll be pretty short compared to this. Okay, so that's it. Hopefully this helped you out, and I will see you in class. So the last little bit we got here, we've talked about subnetting the fourth octet, third octet, variable length, subnet masking. We've seen how that works. So we have structured design of your networks, what things to consider. So we've got planning IP address assignment, how to determine the size of each subnet, number of hosts per subnet, how addresses will be assigned to different devices, whether they be printers, servers, host devices, intermediary devices. How do you want to do it? So it requires some planning. Why? What are our considerations when we're planning these subnets? We want to prevent duplication of addresses, of course. That's going to cause a lot of issues in our network if we have that. Provide access and control for things such as servers and who will access them. Whether or not you want your addresses to be static or dynamically assigned, you're going to have a little bit more control if you're using static addresses. And monitor security and performance. So you'll be able to do that also better if you have static IP addresses. If you're monitoring your network effectively, any problematic devices should easily be found if your addressing scheme is right. Okay. Moving on down, you can have typical ranges for host devices versus servers versus printers, intermediary devices, and your gateway. Well, I mean, this isn't exactly typical. Your gateway, they give it the last IP address in a range. We've been using the first, and that is actually the more commonly used technique. Okay, so there's some common ranges, not always used. Some considerations for IPv6. You do have subnetting of IPv6, but it's a lot easier. We talked about the different portions of your IPv6 address. You've got your global routing prefix, your subnet ID, your interface ID. Okay, so we're going to be talking about or discussing the subnet ID here. So our IPv6 subnets are not concerned with conserving IP addresses. We have plenty of IP addresses. So this is just about organization and assigning different networks. We don't have to use subnet masks or anything like this. It's a lot easier process because you're typically just going to be going in sequential order from 0 on up to whatever number you need in terms of your subnet IDs. So you can see here the subnet would be 0, 1, 2, 3, 4 on down the list. You actually, using this block here, have the ability to create 65,536 subnets. So most likely you're not going to need more than that. And you can also have 18 quintillion host IPv6 addresses per subnet. So yeah, we aren't concerned about addresses in address space. We're just basically numbering from 0 on up and assigning those subnet IDs. So, yep, you're just incrementing up by whatever digit using your hex. It's pretty easy. Nothing complicated like IPv4. And as you're assigning those different subnets to, well, different areas, this graphic doesn't really show you, but you could have subnet 1 up here, subnet 2, subnet 3, subnet 4, subnet 5. You're just going to increase incrementally. So that's about all it's going to be. Let's see if there's a better graphic. Alright. So we got the address block, for instance, here. They give us an address block 2001 0db8 ACAD /48. Okay. We can go ahead and subnet out that address to just, well, 000 would be the network. That's 00 here. 1 would be the first subnet, 2, second, 3, 4, 5, on down the list. You're just increasing by 1. And how that's going to look in your topology, would be like this. So you got 2001, 0db8 ACAD, or 001, subnet 002, 04, 05, you got a 03 over there. So again, there's really nothing complicated about it. You're just using the numbers that are available to you, sticking them in this fourth hextet here, and going about it that way. So again, not really much to it. And if you're going to be, well, setting up those networks, there's the commands. It's nothing different. You just have different subnet IDs in here for your different interfaces. Alright, and that's about it. IPv6 is pretty easy. Nice, short 5 to 6 minute video, which is pretty refreshing after the hour-long first one. So I'm going to end it right here. There's our summary. End of Chapter 8.